Oil, the lifeblood of your engine, performs many functions every time you start your car. This is why engineers continue to develop new formulations to enhance lubrication and extend the life of your engine. One of the more important functions of oil is to form a sufficiently thick and strong film that separates two pieces of metal that come into contact. This lubricating film reduces friction and wear and prolongs the life of the metal parts in your engine. Oil also acts as a coolant and transfers heat. By transferring heat, lubricating oil significantly extends the life of your motor. Similarly, oil acts as a carrying agent to transport dirt, metal, and chemical byproducts that result from internal combustion to the oil filter. Thus, oil also helps to clean and keep clean your engine, protecting metal components from oxidation, corrosion, and deposit formation. All motor oil contains additives to reduce oxidation, corrosion, deposit formation, and maintain a cleaner engine. Additional additives are used to reduce friction and wear, prevent oil foaming, and improve temperature stability and pumpability. Additives improve any motor oil. Oil viscosity is often described as the thickness of oil, but really refers to the ability of the oil to flow at a specific temperature. Thus, oil flows faster when the temperature is higher and slower when the temperature is cooler. The classification of oil viscosity is determined by the Society of Automotive Engineers, SAE. Oil is classified as a single viscosity grade, like a 30-weight or 40-weight oil. Single-grade oils maintain a constant viscosity, whereas multi-grade oils like a 10W30 have a lower viscosity or thinness with cooler temperatures and a greater viscosity or thickness at higher temperatures. A 10W30 oil acts like a 10W when it is cool and like a 30W when it is warm. When an engine is cold, there are advantages to having oil that can be pumped quickly to critical engine components to enhance lubrication at startup. If the oil is thick and slow-moving, obviously it takes longer to provide a lubricating film to protect the engine against friction and wear. Multi-grade oil tends to become less viscous over time with temperature and chemical changes, such as fuel dilution, oxidation, and shearing. Thus, between oil changes, it is not uncommon for a 10W30 to lose an entire grade and become like a 10W20 oil by the time the oil is drained for an oil change. The American Petroleum Institute, API, determines oil service categories for oil used in North and South America and monitors oil quality in the United States and Canada. In 1970, the API developed a dynamic service classification system to certify oil quality. Oil for gasoline engines starts with the letter S. It is commonly thought that the letter S stands for spark, because these oils are formulated for use in gasoline engines that start with a spark. But in fact, According to the API, S stands for service. The second letter of the classification after the letter S indicates the specific generation of oil quality, as in the case of SA, SB, SC, etc. While the first oils had little or no additives, each succeeding API service category has used additives to improve the quality of the oil. Initially, we had SA oils, and today we have SN oils. SB was better than SA, and of course, SN is better than SM. For diesel engines, a different service category was created, which starts with the letter C. It is commonly thought that the letter C stands for compression, because these oils are formulated for use in diesel engines that start by compression. But in fact, according to the API, C stands for commercial. The second letter of the classification after the letter C indicates the specific generation of oil quality, as in the case of CA, CB, CC, etc. While the first oils had little or no additives, each succeeding API service category has used additives to improve the quality of the oil. Initially, we had CA oils, and today we have CJ4 oils. The API also monitors oil quality. Thanks to the API, oil quality is constantly improving due to the use of quality additives which enhance oil performance. Mineral oils are conventional oils which most people use in their vehicles on a daily basis and are refined from crude oil. Semi-synthetic oils are a blend of mineral oil and synthetic base oil. Synthetic oils are more highly refined than typical mineral oils and produce less deposits and have a greater thermal range and a greater extended service life. Synthetic oils provide better lubrication, but cost more money. As we mentioned earlier, additives improve oil performance. That's why it is hard to believe that many oil companies regularly inform consumers that they should not add oil additives to the oil. Let's take a look at some interesting details. Almost all of the big oil companies have proclaimed on different occasions that their oil products are of such superior quality that it is unnecessary to use oil additives to improve the oil. Similarly, most vehicle manufacturers advise vehicle owners not to use oil additives in their vehicles. It is interesting to note that there is a strong contradiction in what they say and what they do. Most of the oil companies not only manufacture, but also commercialize their own line of oil additives. Vehicle manufacturers also commercialize oil additives. Shell, Pennzoil, Quaker State, Valvoline, Mobil, Castrol, and Texaco all sell oil additives. Since the oil companies produce and sell oil additives, why on earth do they tell consumers not to use oil additives with their oils? In other words, don't use oil additives, but you can use our oil additives. One objection is that oil additives were necessary years ago, but today modern oils do not need aftermarket additives. We saw previously that oil is continuously improved as a result of additives, and we have new API service categories almost every few years. How do they improve the quality of the new oils? They use better additives. Another objection used is in regard to balanced formulations. The argument goes something like this. We use teams of chemists to develop balanced formulas, and if you add an oil additive, you will modify the chemical formula and create an imbalance in the formula. From the moment you start your car, the chemical and thermal reactions change the original chemical formulations of the oil. Oil quality is degraded as it fulfills the functions of lubricating oil. And the reason you need to change your oil, apart from being dirty, is because the additives wear out. The fact is, most oils lose an SAE grade between oil changes. And of course, the balanced formula isn't the same when it is drained from the crankcase in an oil change. Now let's talk about why you should use a quality oil additive when you change your oil. Annual testing of oil quality in the United States finds somewhere between 10 and 20% of oil sold in the United States does not meet API specification requirements. Furthermore, in Latin America, the API does not monitor oil quality. There is a high incidence of falsified oil products in many countries in Latin America. The president of one of the major multinational oil companies in Latin America once admitted that approximately 40% of his oil brand in the local market was falsified. In other words, you can't have confidence that the oil you are purchasing is really what it is supposed to be. In many countries in Latin America, obsolete oils, per API classification, are regularly sold to the consuming public. The reason is quite simple. People are not educated about oil. Typically, you don't learn about oil at school. It is not uncommon to see people topping off their oil between oil changes with obsolete oil or even base oil. This oil usually does not contain any additives whatsoever. Base oils will damage a car's engine very quickly, and this can be very expensive. Using obsolete oils will degrade oil quality and will not provide adequate lubrication and protection against friction and wear. Bardahl is a quality oil additive that has been produced for more than 75 years and is sold around the world in more than 80 countries. As Ole Bardahl stated years ago, if we can't make the best additives in the world, we won't make any. Only Bardahl additives have polar attraction. How does it work? Polar attraction is an electromolecular formula that mixes organic polar compounds and special chemicals to form a polar bond with metal surfaces in the engine. These surface-active compounds form a molecular lubricating film on the metallic surface, dramatically reducing friction and wear. Remember, when the engine is parked, oil follows gravity and drips back to the crankcase. The result is a dry start. What's a dry start? When you start your car the next morning after the oil is returned to the crankcase, you can hear the metal-on-metal contact that results from friction and wear and lack of proper lubrication. Bardahl's polar attraction formula maintains a tenacious protective molecular film that dramatically reduces friction and wear. Let's join Orlando Retana of San Jose, Costa Rica, for a quick demonstration of the quality of Bardahl oil additives and the ability to improve any oil in the market to protect against friction and wear.
Good day everyone, my name is Orlando Retana and I'm a member of the Bardahl test group in Costa Rica. Today we're going to work with the demo machine. This is the latest generation demo machine that contains a 110 volt electrical motor. The machine is available with a 110 volt or 220 volt motor depending on electrical power in your country. The Bardahl demo machine demonstrates, in a visual way, the capability of Bardahl additives to improve the properties of motor oil. The pressure between the race bearing and the test bearing is applied through a cylinder with a hydraulic piston, which is connected to the support arm where the test bearing is placed. The hydraulic piston cylinder is a one-piece unit with a pressure gauge, and in the future we will refer to this as the cylinder gauge unit. The race bearing rotates within a small container with motor oil called the test cup, where it is lubricated by the oil and by Bardahl. The pressure gauge, part of the cylinder unit, is a direct reading pressure gauge that allows us to easily observe the amount of pressure exerted between the race bearing and the test bearing. Now that we have observed the different pieces that make up the demo machine, we can now see the Bardahl demo test. One of the most important aspects to make the test a successful demonstration is the cleaning of the machine. A very important aspect is that the bearing must be completely clean. The bearing has not been used in previous tests, which will alleviate any skepticism. The cleaning step is quite important. We're going to do it using a carburetor cleaner probe. In this way, we're going to guarantee that the surface is completely clean. We also are going to use emery cloth or a diamond file, which is going to remove any film or any lubricant that has been used in previous tests. Once the surface is completely clean, we can start the test. It is important that the oil is completely new and the latest generation oil. An API SM oil is currently the most modern oil available. The oil should be poured into the test oil cup, which must submerge the test race completely. With the machine operating, we are going to see how much pressure is necessary to break the lubricating oil film. It is important to note how the race bearing is completely submerged in the oil and also how it is in full contact with the test bearing. I'm going to begin to exert pressure to see what pressure the oil can support. We have now 400 inch-pounds. Now we're going to see what happened to the wear scar with the 400 to 500 inch-pounds of pressure. As you can see, the wear scar is quite deep, with a pronounced roughness using the latest generation oil at 400 to 500 inch-pounds of pressure. Bardahl B1 is an oil supplement. It maintains the optimal operation of new cars and increases mileage while reducing friction and wear in the engine. The Bardahl polar attraction formula is very strong. It adheres to the metal surfaces, forming a molecular layer. Bardahl B1 helps to prevent the accumulation of varnish and the formation of sediments in the valves and camshafts. Bardahl B2 is a very effective oil treatment that improves compression and lost engine power. It reduces oil consumption, reduces engine wear, increases oil pressure, and reduces engine noises. It covers all the metal movable parts in the engine with a very special layer that reduces friction. This special layer is the polar attraction film. We also have Bardahl Special Duty. This product improves engine operation, reduces friction and wear on moving parts, increases mileage, eliminates hydraulic camshaft noise, improves power of older engines, and protects against high oil temperature. Special Duty also has the Bardahl Polar Attraction Film. In this test, we're going to use Bardahl B2. Before pouring the additive into the oil cup, it is important to rotate the test bearing to a smooth, unused surface that is completely clean, so we can easily appreciate the comparison between both wear scars at the end of the test. We also are going to pour the B2 additive into the oil so that you can see that Bardahl B2 mixes perfectly well with the oil. You can see how our additive has mixed with the oil, and now I'm going to place the test bearing in position and I'm going to apply a slow, continuous load of pressure. First, 200 inch-pounds. I'm going to continue increasing the pressure. 400 inch-pounds. I want to remind you that the lubricating oil film was broken at 400 inch-pounds and the machine seized. Now we have 500 inch-pounds. 600 inch-pounds and the machine does not stop. This means that the protective film from the Bardahl B2 is still present, adhering to the metal surface, and we don't have any problem. Our machine is still running. I'm going to increase the pressure, 700 inch-pounds and 800 inch-pounds, and the machine does not stop. Now, what I'm going to do is a test of the Bardahl B2 Polar Attraction Film. I'm going to completely remove the oil test cup with the reservoir of oil, and I'm going to repeat the last procedure with the same test bearing, but this time with only the Polar Attraction Film protecting the bearing. At 200 inch-pounds, the machine does not stop, works without any problem. What the film does is to protect the two surfaces from the friction and wear from metal-on-metal contact. I'm going to increase the pressure to 400 inch-pounds, 500 inch-pounds, and the machine does not stop without any oil. Remember that 500 inch-pounds was the pressure applied using oil in the test. Now I'm going to increase the pressure up to 600 inch-pounds, 750 inch-pounds, and 800 inch-pounds, and the machine does not stop and works without any problem. Now you're going to be able to see the wear scars from the two previous tests. This is the wear scar with the oil at 400 inch-pounds. And this is the wear scar at 800 inch-pounds with only the Bardahl Polar Attraction Film. The machine never stops. It is a totally polished surface, no rough nor deep wear scar. Only a totally polished surface. This wear scar demonstrates the superiority of the Bardahl additives and how our additives improve the properties of conventional oil. This is the way our test finishes. As you can see, the two wear scars, one without and one with Bardahl, demonstrate the benefits of Bardahl additives in any type of oil.
Orlando demonstrated very clearly that Bardahl's oil additives with polar attraction formula improve any brand of oil and significantly reduce friction and wear. Bardahl's polar attraction formula has frequently been copied, but never equaled. Remember, only Bardahl oil additives have the world-famous polar attraction formula.